Yeah, hello. Can you hear me?
Hey, man, it's been a while, man. I've been wanting to talk to you.
Oh, yeah, yeah. Uh, I've just been watching the stream. Sometimes I'm on a completely different stream. It's not related to any of this stuff. It's just like another live stream. But
Right.
yeah, just watching. Me and Scam Chan were just having an argument about he keeps saying that the alternator does this, does that, that, and then like I don't get what he's trying to. Like, he keeps like making circular arguments, but he was saying that the first time he mentioned, well, I think I mentioned something about that's like how the car works when you were talking about how the system works earlier, and he said
Yes.
the alternator is a power source. And I'm like, bro, if you think the alternator is a power source, then you contradict yourself because I mean, y'all been saying like him and identity. They've been saying the whole time that you can't use like MOSFETs or transistors to generate power, but yet you think the alternator is a power source. Like that doesn't even make any sense. But he's been trying to get me to like answer him, and like I told him 3 times earlier in the whole stream that I already answered your question, but he just keeps going around and around. So I was like, all right, whatever. But yeah, I decided to join in because
So
I
what do you think that the alternator do? This is your chance to tell him what do you think an
oh,
alternator does?
so yeah, yeah, yeah. So I was explaining that the alternator acts as like a step up function, right? So he was saying, "Oh, what does it step up? It doesn't step up anything." And I'm like, "Okay, so if it doesn't step up anything, then why do you have the battery in the car? Because the battery is what helps power the system, right? Because you got to understand why is the battery and the alternator even in the car in the first place? Because the way an engine works is that it needs it needs the spark to start the combustion process so the engine can keep going, right? And then yeah, you can use the battery to power the car for a little bit too, but we're not talking about like electric cars here like a Tesla or something. We're talking about like normal combustion engines that uses fuel. So when you're talking about those, you have to understand like why are all these components in here? So the battery helps keep the process going over time. The alternator steps up the energy output from the battery, and then it puts that energy back into the battery to keep the system going for as long as possible. And basically, inside of the alternator, I think you showed this in one of the previous videos where it was a guy showing inside of the alternator with all the MOSFETs inside. I think you remember that.
Yes.
Yeah, yeah, yeah. And so you're showing how the guy was saying that, oh, like one of the MOSFETs went out, so we just replaced the whole thing. And if you understand like what's inside of the alternator that even makes the alternator work, I mean, it's literally in the name, an alternator. What is it alternating? It's alternating the current. So when you understand these things, you start realizing that, well, this is basically the same thing that a MOSFET is doing. It's just it's like a different level of like just it's not even just a MOSFET itself, but it's other things too. So it's like I kind of like I understand to a degree where like sometimes you're trying to argue like, oh well, this doesn't do that, it does that. And that's what I was saying before, like how they like to use like semantics, right? Like wordplay. So
Yes.
they'll get into the specifics of like how a term is used, but you're basically using it in the same way, even if it's slightly different. Like for example, you could say, "Oh, someone is running or sprinting." Well, they're both two technically. Like if you were to go to like an expert runner or something, they would say, "Okay, well, there's a difference between a run and a sprint, but they both are like the same function, right? In a way, it's just a different degree of that function." And then you could say, "Oh, a hop and a jump is a little different too, right? But they're both just a different degree of the same function." So this is what I mean by like semantics when you're getting so caught up on the technical terms that you kind of ignore the whole point. Then you just end up kind of just repeating yourself in this loop and no one can ever really get to the real answer. You know.
Well, yeah, that's the reason why I call them disruptors because they're there to do just that. They don't want you to get your message out, and the whole point is that that is the point is that they don't want this message out because once you start doing these little stuff, I mean, and I'm telling about this is so simple and so easy to do. You know, you start to actually become more independent. So, yeah, could I go in argument and nitpick your argument on how you pronounced everything? Yeah, I could, but why would I need to do that? You know, all I have to do is let you finish, which I did. And then I was like, hey, a alternator and a generator are basically the same thing. One is a direct and one is alternating, just like you said. So I don't need to nitpick things like that.
Yeah,
And
like
it does. And here's the thing
he's.
about an
Oh yeah,
alternator. An alternator needs the battery
yeah,
because the coils in there are they're energized for you to even get any magnetic flux out of it
yeah,
because they don't have any magnets in there. It's an electromagnet.
yeah,
Without the battery, you don't even have the electromagnet for the alternator to work. You see what I'm saying? So this is the reason why they call it an alternator because this you can't they do call it self-induction, but that's a whole nother story. But the whole point is that you need the battery to put into these special coils that they have in order for the alternator to work in the first place.
yeah,
But the alternator does charge the battery. If it didn't charge the battery would run down, your spark plugs wouldn't get the power it needs to fire, and your car will shut off once the battery is depleted. So the alternator must be giving some type of power to the alternator when the engine is running in order to maintain the battery. This
yeah,
is the same thing that we're saying because the alternator constantly runs while the engine is on, and you can pull energy off the battery while charging the battery. This is what we're talking about putting your car in idle so your battery don't run down.
yeah,
That means the engine is running, but you're not driving. That's what we talk about putting in idle. That means now I can play the radio or turn on my lights without running the battery down. So again, you can watch the power level in your car of what the battery is doing and how much energy is on your battery. So if it was very low and you just run it a few minutes, it'll let you know that the battery is going up. So people who say, "Oh, I need a jump," so they jump start your car is running. They take the cables off your battery and he drives away. As long as your car is running, you can look at the battery power going up and up. But most people who see this at that time can turn on the heat, they can turn on the radio, they can do other things. Why? Because your electrical system is doing a whole lot of other things at the same time your battery is charging, like firing the spark plugs. At the same time, your battery is charging. So you start to see that it can do multiple things because you have multiple circuits hooked to it. So you'll also know that if any of those fuses blow, that you're not getting power to power steering or whatever
yeah,
is running. And there's a lot of circuits that's running at the same time that's running either off the alternator or the battery or a combination of both. So yes, a battery can charge and discharge at the same time. Solar powers do that. So anybody who's listening to that and has a solar systems, they will know that we're telling them 100% true that you can do two things at one time, charge and discharge, and that's a normal thing. So yeah, I think what you said was, in your words, correct.
yeah, yeah. Now he's saying that if it's kind of funny too because if they really took the time to pay attention to what they're saying and then sort of uh reference back to like what what you're saying and so many other people have said before about these systems, they'll realize that even though it's a slightly different design or whatnot, it's basically doing the same thing. Like he says, okay, well, you don't need a battery for the alternator, which isn't really true. But then he's saying if you keep the RPM high, the alternator doesn't need a battery. And it's funny because it's like how before they would say stuff like, "Oh, well, where's the
No, no.
energy coming?"
Wait a minute. That is true. If you
Yeah,
keep it
yeah,
high.
yeah, yeah,
No, the reason why is called self-induction. That means if you're turning it at high speed, the back EMF makes the coils have self-induction, and they can run it without a battery.
yeah. I
You can
know
do it.
that
Right.
that's how it works when you jump it with the battery. Yeah, that's what I was saying.
Yeah.
I wasn't saying that he was wrong, but I was saying how it's similar to how they're saying when we talk about when using the systems, how they would always say, well, where is the energy coming from, right? Where's the energy coming from? Because, like, you're not getting this energy for free and whatnot. And we're like, because we're using the battery to start the system. And then we use like something like a MOSFET, or you can use like something like a reed switch. There's many ways you can do this to step up that energy. But that's exactly what the alternator does. So, like, I don't get the confusion here among them. So it's kind of
Well,
funny.
because they're not trying. Look, they don't want you to get the point. The point is, yes,
Yeah,
we need the battery to get the system started. Okay, but once
yeah,
the system is started, guess what? That energy bounce backs to the battery. That's the
yeah,
whole point. We want to stop using the battery and charge up that battery. If it didn't do this, remember, if you turn off your car, the alternator is not running. So therefore your battery is being used. And if you're playing your radio and got all these electronics, the wind shipers, the um what is it, the heat, the air condition, all these things are running, you're going to run down the battery. Okay. So before it fully runs down, what you want to do is turn the car back on to charge up the battery again. This is just common knowledge. Everybody knows that. I mean, you can go and ask a female that simple question, and they know if you turn your car on that the battery gets recharged, and they know what happens if your battery goes dead. They have to go get their car towed. So or they have to get a jump from AAA or somebody to get the system back up and jump. And a jump means exactly what it is. It's a short duration of charging the battery just enough to keep the turn over the car. Once the car is turned over, you can take the jumper cables off because the engine will now um, turn the alternator, and the alternator will charge up the battery. So now you're talking about a system that does two things both ways. You have an input and an output coming in a loop in a system, and they don't like people understanding that these things are running in loops, because when you start to make other system that runs in loops, you're hurting the people who work at energy companies and telling you have to keep paying for power. So if you start to recognize, how do I hook up a system that's similar to how my car runs? First, you have to have an engine. So here, ask yourself, if I put an alternator in an electric car, okay, that means attach it to the motor and let the alternator run off the motor. Can I put energy back into batteries? Now, would you put 100% back in there? No. Would you put some in there? Yes. So it's about how much energy can you put in there. Once you figure that out, then it becomes time, because you now time how long it takes to charge up the battery from that alternator. And if you have more than one battery, you can use that battery